Hello there, and welcome to the ClueCon Weekly podcast studio, where I'm delighted to be here doing a special ClueCon Deconstructed talk with Diego Gosmar in Italy. How are you doing today, Diego?
Good to see you, David, and all the team.
It's great to have you along, Diego. Thank you for stepping into the studio with us and being involved in ClueCon Deconstructed. We're really grateful for that. Which part of Italy are you in?
I'm in Torino now, in the northwest side of Italy, close to France, actually. And I'm really glad to be here with you and the ClueCon team today, yeah.
Very, very nice. I imagine it's a little bit warm over there. Is that correct?
Oh, yeah, it's warm, but you know, we are on the north side, so quite close to the mountains. Actually, I was obliged to do trekking with my children this weekend. So I took on the hill, on the mountains. We walked a lot, more than 10 hours.
Goodness.
So now I'm quite tired, but happy, yeah.
That sounds like a lot of walking. Excellent. Well, thank you for coming in today. I know that we're going to talk about your product, your contact center solution, and your AI and other things that you've got involved in it. But before we come on to that, Diego, just in case people watching have not met you before, can you give us a little bit of a background to you in terms of how you got into the communication space and more specifically your relationship with open source?
Sure. Can you see my presentation now?
I will pop it over right now and we'll get it up on the screen, Diego. I'm just going to do that now. You should be up in the top corner. And there you are. Yes, there's a picture of a very handsome looking Diego there.
Yeah, just a few words about us for people who don't know about me and the company. I'm Diego Gosmar. I'm now head of the international operation at Ingo Group, the owner of Signalab. So I'm one of the co-founder of Signalab. We founded the company 12, almost 13 years ago, actually, here in Torino, in the university campus. We've been involved in several open source projects, starting in the past from Asterisk to FreeSwitch, Camaillio, and other specialized and focused voice over IP open source project. One part of the company is also involved in open source database solutions like MySQL and other now time series database.
Right.
So we are specialized in customer relationship operations, customer caring. I'm also author of a couple of books. I recently published a book about machine learning. I called it the sixth chakra of artificial intelligence. You know, the sixth chakra or third eye is like the energy point for intuition. So I like to think about AI and machine learning just like the intuition to predict, and we will see later, to predict nice stuff and to do nice prediction, nice job about that.
I remember, Diego, back in open source world, which was in February of 2020, I should say, in Fort Lauderdale, you had a very packed room for your talk about machine learning and AI. And just before we carry on, can you see in the bottom of the screen, you've got that thing about screen sharing. Can you just click on the word hide? So it just puts that little label out of the way. Oh, that wasn't very good, was it? Okay. Perhaps you need to reshare. I apologize. I was hoping that it would just get rid of that little label.
Yeah, just let me do something like this. Okay.
Now we've gone to the psychedelic part of the show.
Okay.
There we are. Yes.
Is it okay now? Yeah.
Yeah.
Great.
That's looking excellent. Apologies. I didn't mean to.
Don't worry.
Yeah. I was just saying that I remember your talk was particularly popular because I think people recognised you as a leader, and of course AI, chatbots, and things like that, natural language recognition are all very hot button topics at the moment.
Yeah, in Fort Lauderdale, I spoke a little bit about AI applications, especially for customer care. Today, I'd like to talk a little bit more about AI and machine learning applications for speech recognition, speech analytics, and we will see later also a couple of them about that.
Well, that's great. Thank you very much. Do go ahead.
So, apart from me, a few words about our solution. It's a customer care-oriented solution, Xcolli, named Xcolli, and so it's possible with Xcolli to interact with customer according to the omni-channel paradigm. Okay, so you can get in touch with agents by using voice, chat, email, SMS, or API to leverage the benefit to get in touch with the social media messaging platform. And recently, via API, we've been able to integrate the solution also with some human-to-machine solutions. Let me say AI solution like the Amazon Lex or Google Dialogflow and some others as well. Let's now move on to the topic of the presentation. So about machine learning, how to use that, and what kind of application we can do with that. Before getting inside the technical part, I'd like to spend a few words about a couple of misconceptions of AI machine learning. So the first one is that, okay, now we have AI, we can get rid of a lot of jobs, we can save a lot of money. Actually, this is not really like that, because on one side, we can, of course, do something on the repetitive jobs. But on the other side, we need and we will create more jobs, especially looking at the data scientists, data engineering, system engineers, data scientists to perform the data design. So there are a lot of opportunities as well. The second misconception I sometimes hear is about AI like automation, like robot. Again, sorry to disappoint you, but this is not really about strange cyborgs landing on Earth and helping us with some kind of jobs. It's really more about data science, meaning it's more about data elaboration, data manipulation. We are going to analyze data to find patterns, correlations inside the data, and based on that, we can perform predictions and nice applications. So we can see machine learning like a subset of data science. It's just like during the past industrial evolution, we simulate we use machine actually to simulate physical tasks.
Okay.
Likewise, now we are trying to use AI and machine learning in order to use machine to simulate cognitive abilities. Machine learning. So there are three families, okay, in machine learning: supervised, models, reinforcement learning, and unsupervised learning. What I'm talking today, what I'm going to focus today, is actually the supervised learning model. Okay, so what does it mean? It means that we have the availability of data where we know the input and the output results. So we have some historical data, and we can use those data to build our model. Let's do an example. Let's say that we want to build a machine learning model to perform some image recognition. Okay, we want to be able to recognize some image. In this case, we have in the supervised learning, we have a data set where we already know about the content of the images. For example, we can use the modified National Institute of Standard and Technology database. You can find that on the web. It's free. You can download that. You get 60,000 of images containing digits, handwritten digits, actually, like you see in the image.
Yeah.
Of course, I know that this image is containing 5, 0, 4, and so on and so forth. So I can use this to perform the training and validation of our AI model. We can train the model, fit the model the best we can, reach, and whenever we reach a good result for us in terms of accuracy, in terms of performance, then we have our machine learning model. And now, after the training, we can perform the real prediction. So maybe you, David, or me, we can write a new digit, we can create a new image, and our model is supposed to make the prediction, and in this case, recognize the content of that image. So I'm going to talk today really about those kind of machine learning families. Okay, we have some data, we can use those data to perform the training, and then we have a model that we can use to perform further predictions on the real world.
Yeah.
So the application I'm going to focus today are really the voice, okay, the speech. If you have a customer care, or if you have if you run customer operations, probably you already have a lot of voice recordings, a lot of customer speeches, and that's pretty cool because you can analyze the content, for example, of that voices and try to get some insight about that. For example, you can think about to perform sentiment analysis. I can evaluate if a conversation is, if the customer is happy, or he or she is sad or neutral. So I can perform a sentiment analysis.
Diego, can I just ask a question about that?
Yeah, sure.
Particular thing? Do you think that it's possible in the future to use a branch of that technology to tell whether the customer is in the right mood or frame of mind to buy something?
Yeah, it's definitely possible, and I think even that some big vendor, big players are already using that. So it's not just in the future. I think it's already possible to do that. Amazon launched a service, the Amazon Transcribe, but other players are working a lot on that. And this is a technology already possible and already available. I will show more about that. Yeah, definitely. Another application you can think about is the automation in the voice and chat market. So what it's called chatbot or voice bot, where we use artificial intelligence in order to, again, try to understand the content of a conversation. This time not to evaluate the sentiment, but this time to evaluate a potential answer to the customer. Okay, so we can automatize this kind of reply. In order to do that, we usually need some speech recognition engine, okay, where we speak and the engine is able to translate my speech into text. And then with the text, we can do some great predictions or some great evaluation. What has voice recognition has anything to do with machine learning? But well, getting back to the example I showed you before about the supervised learning, in this case, we can have a database of voice samples as a step one. Step two, we are going to map each voice with the numerical features. Okay, machine learning works very well with numbers. Okay, so we need to have numbers, and to do that, we are going to map a voice, maybe a part of each voice, with proper features. They are called features. Okay, so numerical features, and we can use some technique to do that. You can use signal elaboration technique, Fourier transformation, power density spectrum, and other nice tools that you can use. After you have the features, you can pass the feature, the numbers, to a training model, to an artificial intelligent machine learning algorithm. and you can perform the validation, the test of the algorithm until you are satisfied. And at the end, you have your model to make new prediction. So in this case, I had some samples of voice. I built the model, and then I can use that to make real prediction. Okay.
Okay.
I'm gonna play a kind of dangerous demo with you. It's about a simple ASR where we are going to try to recognize very simple word. In this case, just the pronunciation of one digit number, okay, from 0 to 9, okay?
Right.
So to do that, we can use the free spoken digit dataset is available on the web, as you can see here. They did a very good job. We are talking about 2,000 recordings available, where you got 4 speakers. Every speaker recorded 50 times every digit. Okay, so 50 times the digit 0, 50 times the digit 1 with different pronunciation, cadence, and so on and so forth. Okay,
And
what
this
is
is
very
a
cool.
freely available data set, is it?
Yeah, I put here the GitHub link. You can browse and you can download the data set, and you will be able to play with those 2,000 recordings. Okay.
Right.
What is also cool is that you can add your own recordings here by using a technique. Maybe you want to do that in Portuguese or in Spanish or in other language as well. You can do that. It's also optimized this because they trimmed the files, so there is just the pronunciation of the single digits. Okay, so they trimmed the voice before and after the sounds of each digit. So this is a pronunciation of number 7, for example. But what is important here that we have 2,000 samples, and we can use those samples to perform our training to the model. So what we do for step number 2 is we take those 2,000 voices, and we extract the features, meaning that we map each of the 2,000 digits voice with numbers.
Yeah.
I've used a technique here called MEL frequency capstar coefficient. I don't want to get too much inside that, but this is a technique where you chop each pronunciation, each speech in several frames. You take each frames, you transform in the spectrum, make some filters. This is the discrete cosine transformation. So at the end of the entire process, what you get is for each frame of your voice. Normally, each frame is long from 10 to 20 milliseconds. You get 13 coefficient. Okay, so here I have the map of my 13 coefficient for each frame. Each frame is 10 milliseconds. So depending on maybe the number 1 can last, I don't know, 1 second. So we have 13 coefficient, each one for each of the frame of 10 millisecond duration.
Yeah.
Then we take the features and we send those features as an input to a real machine learning algorithm. What I'm using here is a convolutional neural network. This is also used in the field of image recognition a lot. You can use that also here. In the first phase, you optimize the 13 features via the convolution. You can think about convolution about a set of filters. After the initial convolution phase, what you see on the right side is a real neural network. So it simulates your neurons. We have here a simple neural network. We have an input layer, the flattening one. You have 2 deep learning neural network layers, fully connected, the black ones, and the output layers. So at the end, on the output, this algorithm is supposed to say you, okay, you probably said the number 2 with 0.999 probability, okay? Or
Right.
you said number 5 with very low probability. And so recognize the digit that you said.
Yeah.
Okay, as a step number 4, we are going to test, validate the model, increase the accuracy of the model. And whenever we are satisfied, we can use the machine learning model, in this case, to recognize new voices. Suppose me or you, David, we are going to say 5, and our model should be able to recognize that we are talking about number 5.
Right.
Let's run a little bit about the code for technical people. What I'm using here is a free tool, an open source library. It's called Anaconda, and I'm using a Jupyter notebook. It's pretty much used in the machine learning area. You can use Python and other languages you prefer. I'm going to use Python here because it provides you a lot of mathematical and useful machine learning libraries.
Right.
So
Yes, it's Jupyter itself, or which is which? Is it Anaconda that's a development environment, or is it Jupyter that's a development environment?
Anaconda is the container of several development environments, as you can see here. The Anaconda Navigator, I installed it on my Macintosh. And Jupyter Notebook is one of the environments that you can use. But there are other environments I'm not using here, okay? So Jupyter Notebook, you can use that even on other platforms if you want.
Right.
Even Amazon provide you the possibility to use Jupyter Notebook, okay? And this is cool because I can run through each step here. For example, I can import and see what's going on. Here I'm importing some libraries. Let's use this one. Yeah, here I'm importing the libraries. I'm testing the feature extraction. This is where you see that I extracted 13 features of the signal. We can even print, this is the voice, the number, let's say this is the number 0, the pronunciation number 0 on the time domain, okay? So this is the wave charts of the number 0.
Right.
Then I can go add, I can elaborate the 2000 free samples. I can get, here I'm going to elaborate the 2000 samples. I can calculate the features for that samples and so on and so forth. And then this is the interesting part. You can use, I'm using Keras. It's here on the presentation as well, if you want to take note. Keras is a nice library, a very high level to design neural networks. It's very powerful. It's open source as well. It's very powerful. And you can see here that I'm designing here 2 convolutional levels, as you saw before in the picture. So what I'm trying to do here is to design what you see here, the convolution level and then the neural network, okay? Then we have here the input layer of the neural network and the 2 dense means fully connected neural network. So actually, by using this Keras library, I'm able to create my machine learning neural network algorithm. So I can go ahead. I can go ahead, but I want to restart everything here.
Okay.
I want to show you when the neural network is going to be built here. Okay, you see here the details about the neural network, and here we are going to compile that. And here we are going to train the model. Here we are going to perform the training. I set it for 18 times. You can, of course, change these numbers. So we iterated the process 18 times. We optimized the hyperparameter of the model 13 times to increase the accuracy, as you can see here. And at the end of the day, we have our machine learning model ready to make new prediction. So for example, here, I'm going to predict, let me show you this. I'm going to upload the saved model and I'm going to predict the number 6 in this case, okay?
Okay.
And you can see here it predicted the number 6 with the probability of each number predicted at the end of the day, okay? So this is pretty cool and interesting because you can really, with this environment, debug and run time step by step of what's going on. And it's really powerful as well. So let's get back to the presentation because it's not that easy as it turns to be, of course. There are challenges I want to talk a little bit about. One of the challenges we have is that we want to be accurate, of course. In order to be accurate, we need to have good samples, good availability of data. So I'm talking about those 2,000 of pre-recorded voices, for example.
Just a quick question, Diego, on the accuracy and the models. Are these models standard audio recordings, or are they done over like a telephony connection with all the inherent issues that there might be in terms of denigration?
Yeah, that's a good question. So the recorded we have been using are really quite similar to the voice on the phone because they are recorded 8 kilohertz,
Right.
quite good to simulate a voice call. Okay,
So
we are not talking
they've got
about
a bandwidth
stereophonical,
constraint.
high level, high rated voice. So those are quite good recordings to simulate voice calls. But you can do even better, of course. Maybe you can record some real conversation on the phones and then use that as your own samples. Of course,
Yeah.
I'm not an English mother tongue, for example. So for sure, my pronunciation is not like that. If I want to do a good job, probably I need to create new samples here, pre-record samples, and then the ASR will be able to recognize my voice and let me say the Italian English speaker voices better, of course.
Which is excellent, Diego. I appreciate your excellent English and the poetic way in which you deliver it.
Thank you. But I'm trying to do my best. I can always improve that. So challenges we have is to have that kind of data set, of course, and get rid of noises, outliers, or maybe try to simulate that as better as we can. The other problems we have with AI is sometimes the more difficult, the more complex is the algorithm, the more difficult will be to debug that and even to explain the reason the AI took that decision. Here we are talking about recognition of a voice. But imagine you are talking about, I don't know, you want to use AI to predict and to understand if a guy can access to a bank credit or a loan or not. If you're using a very complex algorithm, it will be almost impossible to explain why the machine learning AI algorithm took that decision. And there are startups I knew that they are working a lot on this problem. It's called the black box dilemma. It's also an ethical problem, of course, in order to make the AI more explainable. So this is the problem about AI explainability. In order to improve the accuracy, you can use some techniques. The ensemble techniques, there are two main techniques you can use. The bagging, basically you are going to run multiple times the models, but in parallel to reduce what it's called the overfitting. On the other hand, you can use the boosting, which is a sequential way to iterate the model, not parallel but sequential, to reduce the error. Okay, two techniques that you can use to increase your performance. And then, of course, we're talking about very simple application. Okay, how to recognize one digit. But of course, what if I want to recognize a complex conversation, like natural speech recognition? Okay, I want to recognize full sentences, complex sentences. Okay, in this case, of course, things get more complex. In this case, it's important to be able to use machine learning algorithms optimized for what is the time sequence, where the time sequence is really important in this case, okay?
Yeah.
And so they need to have some kind of memory. So a simple neural network probably is not enough. If you want to manage this time sequence, you can use what is called a recurrent neural network. The main difference here is that each layer, each node of the neural network is interconnected, not just feed forward with the other nodes, but also they can be connected backwards, or you can see you can have loop. In this case, those kind of neural network performs much better to do such kind of prediction. Or you can use other complex machine learning technique like hidden Markov models, where you use a state machine, also pretty useful when the time sequence is very much important, okay? The second and last application I want to talk about is how to analyze the voice, not to make voice recognition, not to understand the content of the voice, but in this case, to identify you. So how many times we just called and we presented a complex IVR, maybe asking us, imagine you want to do some check on your banks or on your insurance or anything like the customer operation, and they ask you for complex password, PIN code, identity to, of course, verify your identity. Wouldn't be nice.
Just to ask a quick question, is this in the realm of natural language? I know we're not trying to recognize exactly what's said, but is this natural language or is this more of a directed dialogue kind of model?
Yeah, it's about natural language. And the purpose here is not to recognize the content, not to understand what you are saying actually, but to understand that this is your voice and not the voice of your wife, of course.
I understood.
So
more
it's, yeah,
speaker.
this is about the identity verification based on your voice print. Unique voice print, okay? So maybe you are calling, it would be really nice that you call your bank, you speak naturally, okay, this is David Fed, I want to check my bank status, blah, blah, blah. And then on the other side, there are no complex IVR. They just will reply you, okay, we've been able to recognize you, David, based on your voice. You can go ahead. In order to do that, we can use machine learning as well. Just like before, we can map your voice with some numerical features. You can use Fourier or wavelet transform or some other techniques to map your voice with significant features. And then the first phase, the training phase, also called enrollment phase, you will pronounce something, you will speak about something for 2, 3, 5 times. So the system will be trained. The system will store your voice print on a database. After that,
Diego, I remember just now you were saying that even when we're recognizing speech, it all has to be turned into numbers because AI likes numbers. And this is the same, is it? That our voice print, for want of a better expression, is some number-based thing.
Yeah, it's similar, but the aim is again not to recognize the content of your voice. We don't want to make speech recognition now. We want to be able to recognize your voice print and recognize that this is your unique voice. Okay.
Yeah.
So if I'm able to do that, then I can grant you access, for example, to your bank account or something like that.
Indeed.
But the principle is really the same. The principle is really similar. Okay.
Yes,
We always need to. Yeah, precisely.
This technology used to be known as speaker verification and identification.
Yeah.
Is that still the case?
Yeah, that's exactly what I mean. Yeah.
Okay, and of course, we'll carry on in a moment, but I think it's possible, isn't it, to take the same utterance and perform speaker verification and identification on the one hand, but also if you wanted to, and I know we don't right now, but if you wanted to, you could perform speech recognition on the same utterance with a different model.
Yeah. This is correct. This is correct. Yeah, this is correct. So this is just another kind of application. I'd like to wrap up a little bit now about two things. The first one is about skills. So machine learning AI, of course, will try to replace jobs, repetitive tasks. But on the other side, more opportunities will arise, especially for data engineering, data scientists, and everything about the data science will create and is already creating a lot of jobs opportunity. On the other side, it's important to notice that what I spoke today, so about the possibility to use machine learning for speech recognition, identification, and so on, it's not a static process. It's a continuous process. It's important to constantly make the training to your machine learning model, okay? To adapt your models, in this case, to new pronunciation, to new speakers, new condition, new environments. But generally speaking, it's important. Yeah.
Can I just jump in and ask a question about that? Just as a very, very rough percentage, what would you say the split is between developing in the system in the first place and putting it in, and then the ongoing iterative process of optimization?
Oh, well, that's a good question. I think we are talking about almost a 50-50 process. Of course, there is an initial phase where you have a lot of job to do because you want to train your models, you want to identify the best algorithm to use. I used here convolutional neural network. Maybe you want to use recurrent neural network or supported vector machine or other machine learning algorithms. After that, of course, you have a result, but what you need to do is maybe once a week, once a month, depending really on the application that you have, maybe even once a day, you want to repeat again this kind of training procedure to improve the model continuously. And that's important because, of course, the better prediction you can do, the better customer experience, of course, you can provide. And at the end of the day, more sales, it means you can even create and get more data. So this is a virtual circle, you know what I mean, that you are going to create. Pretty much important to provide a good service with such kind of techniques. If we want to talk now a little bit less about technique and more about business, yeah. And what is nice is that almost everything I showed you today, it's available open source. There are a lot of libraries and tools that you can use, and they are available just like that. Just I use that. You can use them on a service on the cloud, or you can install the libraries on your computers. It's the technology is really there if you want to do that.
Good stuff.
So thank you, David. I really appreciate it. If there are any questions or anything you want to dig more, just ask. I will do my best to try to answer.
I'm going to pop you off screen share and so we can see each other better now. Thank you for coming along, Diego. As always, a great presentation with some good meaty content from somebody who's actually in there and doing it. And thank you for highlighting the fact that some of these tools are available in the open source community as well.
Thank you, David. It was really nice to talk with you today and all the community.
Excellent. Thanks. Good to see you again, Diego. It's always a pleasure to meet up. And I'm hoping I get to see you at some real life event sooner or later. In addition,
yeah, not just virtually, but we can meet each other in person, maybe again at next ClueCon. I don't know where, in Chicago, maybe next year.
That would be good. But for now, of course, you'll be involved in ClueCon Deconstructed, which is August 4th to the 6th, online. Lots of fun, all the usual ClueCon things, but moved online. So if you can imagine, the Coda Games is online, the karaoke is online, the jam session is online, as well as
a lot
all the
of
great
stuff.
That's right, all the stuff you'd normally get. Anyway, for
Thank
now,
you.
Diego, thank you very much for coming along, and I'll see you next time.
Thank you. Bye-bye. Take care. Thank you a lot.
Ciao, ciao.